we'll focus on training technicians to accurately identify the cause of icing, whether it's filter-dryer blockage, TXV restriction, or dirty coils, before you replace any parts. We'll cover how to recognize early symptoms, use the correct testing tools, and apply safe diagnostic methods. So, let's get started, and make sure you're fully equipped to handle these common issues effectively. Let's take a closer look at the system overview for the Zamil PMY-840 refrigeration cycle. This system uses R22 refrigerant and is equipped with twin compressors, which helps improve efficiency and capacity. The expansion device employed here is a TXV, or thermostatic expansion valve, which precisely controls the flow of refrigerant into the evaporator. Each circuit in this system has its own set of components: a filter dryer to remove moisture and contaminants, a sight glass to monitor the refrigerant's condition, and service valves for maintenance and troubleshooting. Now, regarding the flow direction, it starts at the compressor, where the refrigerant is compressed and sent to the condenser. After condensation, the refrigerant flows through the filter dryer, which ensures the system stays clean. Then it passes through the TXV, which regulates the flow into the evaporator. Finally, the refrigerant absorbs heat in the evaporator and returns through the suction line back to the compressor, completing the cycle. Understanding this flow and component arrangement is key to grasping how the system operates efficiently and reliably. All right, let's take a look at the tools and setup required for the PMY-840 diagnostic test. First, you'll need an analog manifold gauge. This is essential for accurately measuring the pressure in the system, giving us real-time data. Next, clamp thermometers are important for measuring the temperature at specific points, which helps us assess system performance. An infrared thermometer is also a valuable tool. It allows for quick, non-contact temperature readings, making our diagnostics more efficient. You'll also need a nitrogen cylinder with a regulator. This is crucial for testing the system's pressure integrity and for charging or flushing the system if needed. Lastly, don't forget the cleaning tools, which are necessary to ensure all components are free of debris or contaminants before and after testing. Having these tools ready and properly set up is fundamental to conducting a thorough and accurate diagnostic. It ensures that we can identify issues precisely and perform effective repairs, which ultimately supports the overall goal of maintaining optimal system performance. All right, let's walk through step 1, gauge connection. The first thing you want to do is connect the blue hose to the suction port, which is the low side. This is where the refrigerant enters the gauge. Next, connect the red hose to the discharge port, which is the high side, where the refrigerant exits the system. Once everything is connected, go ahead and run the unit for about 10 minutes. This will allow the system to stabilize, giving us accurate pressure and temperature readings. After that, make sure to record the pressures and temperatures carefully. These readings are crucial for assessing the system's performance and ensuring everything is operating correctly. Remember, proper connection and consistent monitoring are key to a successful gauge connection process, which ties into our overall goal of maintaining and troubleshooting HVAC systems effectively. Now let's move on to step 2, the filter-dryer blockage test. Here, we're looking for specific symptoms that indicate a blocked filter dryer. One key sign is having a normal high side pressure but a low side pressure. This suggests that the refrigerant isn't circulating properly through the system. You might also notice that the liquid line feels hot before the filter but turns cold after it, which points to a restriction. Additionally, frost at the filter outlet is a classic sign that the flow is being impeded. When you see these symptoms together, the conclusion is pretty clear. The filter dryer is blocked. The action to take is to replace the filter, pull a vacuum to below 500 microns to remove any moisture and contaminants, and then recharge the system with R22. This step is crucial because a blocked filter dryer can cause performance issues and damage the system if not addressed promptly. Let's move on to step 3, which is the TXV malfunction test. Now, when you're diagnosing issues with the TXV, there are some key symptoms to look out for. First, you might notice that both sides have low pressure, which is unusual and indicates something isn't quite right. Additionally, the suction line may feel warm, and the superheat could be greater than 20 degrees Celsius. This suggests the refrigerant isn't being properly controlled. Another important point is that you'll likely see no frost at the TXV outlet, which is a sign that the expansion valve isn't functioning correctly. Based on these symptoms, the conclusion often points to either a restricted TXV or a faulty bulb sensor. Both of these issues can disrupt the refrigerant flow and affect system performance. So, what's the action here? The first step is to check the TXV screen and ensure the bulb contact is secure. These are simple but crucial checks to confirm whether the TXV is operating properly or needs further attention. This step helps us pinpoint the root cause and move towards an effective repair, keeping the overall system running smoothly. Let's take a closer look at the system performance test for pressure and temperature verification, specifically for R22 systems. First, you'll notice the connection points. The blue hose indicates the suction line, and the red hose is for the liquid line. These are crucial for accurate readings. Now, under normal R22 operating conditions, the temperature readings should fall within certain ranges. For example, the low side pressure typically reads between 65 and 75 psi, while the high side should be between 220 and 250 psi. When it comes to temperatures, the suction line temperature should be about 10 to 15 degrees Celsius above the saturation temperature, and the liquid line should be 5 to 10 degrees Celsius below saturation. Understanding these parameters helps us interpret the system's health. For instance, if the superheat is less than 5 degrees Celsius, it could indicate an overcharge or that the TXV is fully open. Conversely, if superheat exceeds 20 degrees Celsius, it might mean there's low refrigerant or a blocked filter, which hampers proper flow. Looking at subcooling, if it's less than 5 degrees Celsius, it suggests a low refrigerant charge. On the other hand, subcooling above 15 degrees Celsius could point to an overcharged system or poor airflow across the condenser. Connecting all these data points, we can accurately diagnose and troubleshoot system performance, ensuring everything runs efficiently and reliably. Remember, these measurements are key to maintaining optimal operation and preventing potential issues down the line.